What's up guys, Sir Gian here, and for tonight, I'm going to discuss to you in finding the area of a regular solid using integration. So suppose we have here a certain function. And that is somewhat irregular in a curve, and you need to find the area of this certain area. So what will be the step they're going to do? Okay, so basically, we strip the area by segments using trapezoids. And for this case, if we have a regular figure such as this, I can simply strip it out like this. Strip 1, strip 2, strip 3, strip 4, etc., etc., etc. And for every strip, I'm going to call that as dx. Okay? And we know that the sum of this would be equal to the total area. So if we have two curves here and another curve here, okay, so I'm going to call this as an L of x, okay, and this would be our g of x, okay. So that the area, we know that that's the real sum, okay, of the function. So that would be, okay, so we have here a certain limit from a to b, okay. So we can call that such that it would be the area is then equal to the integral of the upper function, if we're going to use this kind of element or the horizontal or the vertical element, so that would be the integral of f of x, which will be the upper element, okay. G of x would be our lower element. So that would be f of x minus g of x, okay, getting the integral of both functions with respect to x dx, running from the limits from a to b. So that would be our first thing to consider for this kind of equation. Okay. Now, suppose we have a sample problem. Okay, let me erase this first. Ready to go for this sample problem. Okay. So suppose we have a sample problem. Okay, so we're asked to find the area bounded by y equals to 11 minus x raised to 1/2. The lines 3x is equals to 2, x is equals to 10, and the x-axis. Okay. So, how are we going to solve this problem? Okay. So find the area bounded by y is equals to 11 minus x raised to 1/2, the lines 3x goes to 2, and x goes to 10. And then the x-axis. The first thing that we're going to do is to sketch the curve or to sketch the trace. So for this case, okay, so I'm going to have a Cartesian coordinate or Cartesian plane here, okay. So we need to find first 3x goes to 2. So what is this line? So suppose I have a line here up to 10. Actually, know that x equals to 10 is simply this line. So this would be our x is equals to 10. So 3x equals to 2, we need to manipulate this equation. And we know that 3x is equals to 2, okay. Both sides multiplying by 1/3, okay, distribute that. So then have 3x over 3 is equals to 2 over 3, cancel 3, so that x is equals to 2/3. So we now have the critical values 2/3 and 10. So I'll assume, so if this would be our 1, so that would be somewhere here. So this would be our x is equals to 2/3. Okay. So the x-axis is simply this axis. So if we have x, and this would be our y-axis. Okay. So reviewing your analytic geometry, so we know that by default this would be our x and y axis. Okay. So this curve 11 minus x raised to 1/2 is simply a parabola. Okay, so that would be curving something like this. So we need to find the area bounded by this part. Okay. So we need to identify what is our upper y and our lower y, or whatever or what kind of element we should use. So actually, if we're going to inspect this figure, okay, so we can either use a vertical element. If we're going to use a horizontal element rather, okay, the area would then be equal to the integral of x right minus x left, okay, bounded by the lower y and then y upper. Okay. For this case, since we're going to use horizontal element, the area would then be equal to the integral of, okay, the y upper, or the curve for the y upper, which is y equals to 11 minus x raised to 1/2, okay, minus our y lower, which is the x-axis, where y is equals to 0, integrating with respect to x, okay, running from our x is equals to lower x, okay, 2/3, running from 2/3 to 10. And we're now ready to integrate. So the area would then be equal to the integral of y upper, which is equals to 11 minus x raised to 1/2, minus y lower is equals to y is equals to 0, or simply we can write there 0, okay, quantity dx running from 2/3 to 10. Okay. So the area now would then be equal to, okay, the integral of 2/3 to 10, 11 minus x raised to 1/2, and integral of 0 is simply none. So we can simply neglect that. Okay, dx. Now, we can integrate this using integration by substitution. If we let u be equal to 11 minus x, then the derivative of u would then be equal to dx. Negative dx since we have negative x. Then we have a neutralizing factor or balancing factor equal to -1. Okay? So let me erase this first, so that I'm going to have a space. Okay. So from here, okay, so we have integrated this, and now we can now simply substitute u into the x, so that the area or the equation can be rewritten as, getting the neutralizing factor force -1, the integral of the lower bound 2/3, upper bound 10. Since this is our u, we can simply substitute that with u. So that would be u raised to 1/2, okay, du. Okay, integrating with respect to u, so that our area becomes -1 quantity. So u raised to 1/2, we can use power rule here. So that will be +1 over 1/2 plus 1. And that becomes u raised to 3/2 over 3/2. So 3 is equal to, so we can simply write it that way. And then our limits from 2/3 to 10. Okay. We cannot yet substitute 10 and 20 over here and evaluate the definite integral. So the area would then be equal to, substituting back our u 11 minus x. So that would be -1 quantity 2/3. Okay, we can factor it out. Okay, our u, which is 11 minus x raised to 3/2, running from 2/3 to 10. And by evaluating, the area would then be equal to, okay, so that would be -2/3, okay, times, okay, so times 11 minus x raised to 2/3 at 2/3, or rather 3/2 at 2/3, minus, or rather plus, since this is negative plus, 2/3 11 minus x raised to 3 halves evaluated at x is equal to 10. So operating this, our area would then be equal to approximately equal to, so that is approximately equal to 21.478 meter squared. And that would be our answer for this problem. So do you have any questions or problems with regards to this example? So if you have problems, if you have hesitations, you have confusions, don't hesitate to send me a private message.